Are we ready to look at mirrors? Okay. Let's look at mirrors. So again, I don't want to do concave and convex. I'm just going to do converging or diverging. How do we draw mirrors? So lenses have both sides, correct? Mirrors will have one side. So let me do converging first. What's the focal length for a converging mirror? Plus. And a converging mirror is going to be, it converges in, so it's going to be that shape, and I fill this in. And I'm going to write focal length will be plus 10. That way I'll remember it. I'm going to use the same criteria. Focal length at 10, object at 15. And remember, it is a mirror now. So I can use how many focal points? One, right? So we have to pick the one we use. So both focal and parallel will go through the same focal point. Okay, so let's do the parallel first. So it starts parallel to the surface. And because it's a converging case, it converges in. My chief ray starts again here. And technically, for the other case, remember it went in here. But this is now a reflecting surface. So in this case, it has to be reflected back. And without using angles, here's a quick, easy way to do this. Draw your object to the same height as the object height, but under. And copy this line so that it hits this and goes here. Get it? Without actually worrying about, you know, the angles and stuff. But recognize that this angle has to be the same as that angle. That is what law of reflection says, right? Okay, the last one is my focal ray. My focal ray has to go through the focal first, right? F, focal. Which focal does it need to go through? The one on the left or the right? Good. The same focal. You can't change the focal in mirrors. So then it'll go through. And remember, the light all has to go this way. So your focal ray will start at the top here, go through the focal length, and come hit down here somewhere. And what does the focal ray do after it hits? It goes parallel. And where do all three meet? This spot right here. And that's where your image will be. Do you notice that I always draw my images from the optical axis? Everything is done with the optical axis. Now, this is your eye. For a mirror, this is the real space for object, and this is also the real space for image. So on the same side, it's the real image space for object and for image. Whereas this is the virtual. Virtual space for object and virtual space for image. Okay, now diverging. Yay. So we should have a diverging mirror. So for a diverging mirror, the focal length will be plus or minus? Minus, right? So the focal will be minus. Okay, keeping all our requirements exactly the same. My focal will be at 10. My object also same at 15. The same three rays, principal, chief, focal. Okay, so now look at this. This is a diverging mirror. What will the symbol for a diverging mirror be? And it's a mirror, so it's a reflecting surface. Use these words carefully. So my principle will be this. It has to bounce back. By how much does it have to bounce back? Depends on this focal length. So when it was converging, it converged inwards. And now that it's diverging, it is going to use the other focal point. So that means for my focal ray, which focal point will it use again? The same one. So you start from parallel ray, that will tell you which focals you need. Okay, next ray. What's my next ray? Chief, EA. But it won't go in because it's a mirror, right? And what's the trick I told you? Draw this here, and then this is where it's gonna go. So chief doesn't change much. And dotted line means that these rays actually don't go there. They're just there to help us. What will my focal ray do? It has to go through the focal point first, right? And it has to use which focal point? The one on the right. Okay, so how does it do that? It actually will go, the ray will go this way through here, right? But it doesn't actually get to the other side. And then because it has to bounce back, it's going to bounce back here. Now, do these three rays meet anywhere? And the answer is no, they don't actually meet anywhere. So I have to extend this ray backwards. And now, in fact, they do meet. And they all meet at this spot right here. And that's called the image. Now, is this image going to be a real or a virtual image? Good, because it is behind the mirror. So that's going to be a virtual image. And this is a real object. So for homework, I want you to do this one.